Dundigal. My name is Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about definitions and terminology on color image processing. What do you mean by color model? A color model is a specification of 3D coordinate system and a subspace within that system where each color is represented by a single point. Therefore, an image, a great deal of extra information may be contained in the color, and this extra information can then be used to simply image analysis. Example, object identification and extraction based on color. So, in the previous we discussed gray images. Gray images means black and white. But now we are discussing about color image. Most color images are using in a 3D artistic work and like this. But color image is nothing but in the form of red, green, blue like this. Okay, majority of this one. So a color model is a specification of 3D coordinate system and a subspace within the system where each color is represented by a single point. And therefore, in image, a great deal of information may be contained in the color, and this extra information can then be used for simply image analysis. Example, object identification and extraction based on color. Suppose one object is there, maybe if it is color, then easily identify the image. Easily identify the object. So that is the advantage of color. The human visual system can distinguish hundreds of thousands of different color shades and intensities, but only around 100 shades of gray. So human visual system is a hundreds of thousands of different color shades are there. So different color shades are there on many colors, but three independent quantities are used to describe many particular color. The hue is determined by the dominant of wavelength. Suppose human visual system. What is the contrast level of the human system? Human visibility system is important. So human visibility system in the color image is the dominant of wavelength, that is hue. Okay. So first, human visibility. How much visibility of the image color, that is nothing but a wavelength. So this process I am calling as a hue. The visible colors occur between 400 nanometer violet to 700 nanometer red. So what is the range of human visible system is there? 400 nanometer to 700 nanometer. So 400 nanometer is nothing but a violet, 700 nanometer is nothing but a red. So three independent quantities are used to describe any particular color. Is a hue is determined by the dominant wavelength, and visible colors occur between about 400 nanometer is a violet and 700 nanometer red on the electromagnetic spectrum. Okay, it is about the color system or range of color in the wavelength. And what are the brightness bodies? What are the brightness bodies are there? So brightness bodies are achromatic notion of intensity, and it is a key factor is describing color sensation. Already in the color model, there are brightness embodied for achromatic notion of intensity in a key factor in describing color sensation. So I am taking the wavelength of this one. From left side I am taking the shortest wavelength, right one I am taking as a longer wavelength. In the previously we discussed the wavelength is a range of 400 to 700 nanometer for human visible system. Human visible system. So in the visible spectrum, shortest wavelength and the longest wavelength. It is the gamma rays of 10 power minus 3 nanometers. X-rays are 10 power minus 1 nanometer. And infrared is a 10 cube nanometer. Radio waves are 10 power 9 to 13 nanometers. Okay. So, visible system is from 400 to 700. What is a visible system? It's human visible system. Human visible system is from 400 to 700. So between the 400 to 500, the color is blue. Between the 500 to 600, the color is green. Between the 600 to 700, the color is red. So shortest wavelengths are gamma rays, X-rays, and ultraviolet, 10 power minus 1 nanometer. And the longest wavelengths are infrared 10 cube nanometer, and radio waves are 10 power 9 to 10 power 13 range of nanometers. Okay, as per human visual system, we are dividing as a 3 colors: blue, green, and red. Blue is nothing but around 400, that is a 436 nanometer. Green is a 546, that is around 500. Red is a 700 nanometer. Okay, so what are the primary and the secondary colors? There are 3 primary colors are there: red, yellow, blue. 3 primary colors: red, yellow, blue are the 3 primary colors, and orange, green, violet are the secondary colors are there. And the color spaces are different types of color modes used in image processing and signals and system for various purposes. Some of the common color spaces are RGB, CMYK, HSV, and YAK. We will discuss each one next. So color image processing are the 2 types. Primary colors are nothing but red, green, blue. It is also called RGB. It is also called OGB. The color spaces are different types of color modes used in image processing and signals and the systems for various purposes. Some of the common color spaces are there. That is the RGB, CMYK, HSV, and YAK. So we will discuss each one. Achromatic versus chromatic. So what is the achromatic? In the previous slide we discussed brightness embodies as the achromatic notion of the intensity and is the key factor of described color sensation. So what is achromatic and chromatic? So achromatic light is nothing but a void of color. Only attributes is its intensity measured by gray levels. Example, black and white. That is a TV, the kind of images that will be discussed so far. And the chromatic lights are wavelength from 400 to 700 nanometers. Okay, so when we are going for the chromatic, so 400 to nanometers to 700 nanometers, that is a chromatic. And what are the achromatic? Achromatic is nothing but a void of color, only attributes of intensity measured by gray levels. Example, gray levels, that is black and white, and TV. So black and white TV like this. Okay, the 3 basic quantities are used to describe the quality of chromatic light source. That is a radiance, total amount of energy that flows from light source in watts. So 3 basic quantities are used to describe the quality of a chromatic light source. So radiance, the total amount of energy that flows from the light source in watts. So luminance, amount of energy an observer perceives from a light source in luminance. Example, for infrared light has large radiance, but an observer would hardly perceive it. And brightness, similar to the achromatic notion of intensity, one of the key factors is describing color sensation. Achromatic and chromatic is there. Achromatic and nothing but a black and white color is there, and chromatic means nothing but a 400 to 700 nanometers we are taking. So in the luminance is nothing but the amount of energy an observer perceives from a light source, that is a lumens, LM. Example, for infrared light, what is the range means? Highest range of light is an infrared light, has a large radiance, but an observer will hardly perceive it. And brightness is nothing but a gray level, that is in the form of black and white. So that is a acrotic notion of intensity. One of the key factors is describing is a color sensing. So what are the primary colors and secondary colors? We are differentiating. So primary colors versus secondary colors of light. So what are the primary colors? Red, green, blue, RGB components of acting alone can generate all spectrum colors. And what are the secondary colors? Means magenta, cyan, yellow. So magenta, cyan, and yellow. So magenta is nothing but a red plus blue. Cyan means G plus B. Yellow means R plus G. So magenta and cyan is a combination of primary colors. So the combination of primary colors are nothing but a secondary colors. So what are the primary means? Red, green, blue, RGB. What are the secondary colors means? Magenta, cyan, and yellow are the secondary colors. So R plus G is the magenta, G plus B is the cyan, and yellow is a R plus G, red plus green. That is the secondary colors. The mixing of three primaries are the white light. Mixing of three primaries are called white light. And primary colors with secondary colors. Here light, here pigments. It is a primary versus secondary with light. Here primary versus secondary with pigments. So primary colors are magenta, cyan, yellow, absorb as a primary color of light and reflect of transmitting of other. Secondary colors are RGB. So when we are going of the pigment, RGB is a secondary and magenta, cyan, yellow are the observing as a primary color for reflecting or transmitting of colors. Okay, that is a pigments. RGB stands for red, green, and blue. And RGB model states that each color image is actually formed of three different images. Okay, so three different colors are the three different images are there. So red image is different, green is different, and blue is different. So RGB stands for red, green, and blue. But RGB model states that each color image is actually formed of three different images. Red image, blue image, and a black image. A normal grayscale images can be defined by only one matrix. But a color image is actually composed of three different matrices. One color image matrix is called the red matrix plus blue matrix plus green matrix. Okay. So any of the one color image equal to red matrix plus green matrix plus blue. That is a color image. When I'm going for the gray image, so when I'm going for a normal grayscale image can be defined as a one matrix, but a color image is actually composed. One matrix combination of black and white. So combination of black and white is a one matrix. But here matrix 1, matrix 2, matrix 3. So color image is a combination of three matrix. Matrix 1 is red, matrix 2 is green, matrix B is the blue, RGB. But grayscale matrix is only one matrix, that is a combination of blue and black and white pixels are there. So here one example of RGB. Here I'm taking red matrix, green and blue matrix. So it is red is converting to the black, green is converting to the white. Here white and black combinations. Here white and black combinations. So red I'm converting to the grayscale. Majority of this one is a black. Here it is a partially white and black. Partial white and black. Here balanced black and white. Here majority of partial white and black, but here partial and majority of white and black. It is the conversion of RGB to gray level or grayscale. So what are the color combinations? Green 255 plus red 255 equal to yellow. Already we know that. What are the intensity levels? 0 to 255. That is a 256 is the intensity level. Intensity level of any color. So if I'm taking that 255 means maximum complete green. Suppose here I'm taking suppose 120 like this means partial green. So here 255 means complete green plus complete red equal to yellow. Complete green, complete blue equal to cyan. Complete red plus complete blue equal to magenta. Red plus green plus blue equal to white. So the combination of red, green plus blue, R plus G plus B equal to white is equal to 255. It is 255. 255. Okay, it is a color combination. I'm talking about CMYK. It is also color combination. So the conversion from RGB to CMYK is done using this method. CMYK color model is widely used in printers and it stands for cyan, magenta, yellow and black. It is a subtractive color model and 0 represents the primary color and 1 represents the light color. So it is a model of 0.111 represents the black and 000 represents the white, and it is subtractive model, thus the value of the subtracted value from 1 to vary from the least intense to a most intense color value. So CMYK is a conversion from RGB to CMYK. So red, green, blue to CMYK is done using this method. CMYK color model is widely used in printers. Okay, mostly widely is used in printers. Okay, is using in images conversions. So CMYK color model is widely used in printers and it stands for cyan, magenta, yellow and black. Black is a key role. And it is a subtractive color model. 0 represents the primary color. If it is 0 means primary color. Lighter color. This model 1 represents the black, 1 is represents black, and 0 represents the white. So black and white, why I am telling you 0 means when you are converting from CMYK to black and white or gray levels. Black is nothing but 1 and white is nothing but a 0 here they are taking. And here CMY means C of 255 intensity, Y M of 255, Y of 255 intensity values here I am taking. So that is the CMY minus RGB. So what is happening? So CMY equal to cyan, magenta and yellow is nothing but a 255 minus of red, 255 minus of green, 255 minus of blue. It is nothing. This it is nothing but a C. It is nothing but a M. It is nothing but a Y. So consider you have in a color image means you have a 3 different arrays red, green, blue, and we want to convert an image CMY. Here's what you have to do means we have to subtract it by the maximum number of levels from -1. Each matrix is subtracted and its respective CMY matrix is filled with result. So each matrix levels of -1 and each matrix subtracted 255 minus or subtraction with C 255 minus green of subtraction magenta, 255 minus subtraction of blue is Y and nothing but a yellow. So 1 minus RGB equal to CMY. So 1 minus RGB, 255 minus R equal to C. So 1 minus RGB equal to CMY. So CMY is nothing but a 1 minus of RGB. That is the equation. So 1 minus RGB equal to Cn by Cn is negative of Cn is a negative of red, magenta is negative of green, yellow is negative of blue. So it is the some combination of colors. What is the Cn means? What is the Cn? How happened means Cn is happened with this color. Cyan, magenta, red, yellow. So what is this one? Cyan plus yellow. Cyan plus yellow equal to green. Cyan plus magenta plus yellow equal to black. Magenta plus cyan equal to blue. Magenta plus yellow equal to red. Okay, this is one. So combination of three colors, that is a black here. Here two combinations, magenta plus yellow. Already we know that red, green, blue. So combination of secondary colors equal to primary. Combination of secondary colors equal to primary color. Combination of secondary colors equal to primary color. Red, green, blue. So RGB combination of secondary is equal to primary. Combination of primary equal to secondary. Combination of secondary equal to primary. These are the color combinations of color model. Pseudo color processing is an important role. So what is pseudo color? It is one question. So pseudo color is a technique that maps each of gray level of a black and white image into a assigned color. This color image, when displayed, can make the identification of certain features easier for the observer. The mappings are computationally simple and fast. So what are the two major areas are there? Full color processing and pseudo color processing. So what is pseudo color? It is a technique that maps each of gray level of a black and white image into an assigned color. This color image, when displayed, can make the identification of certain features easier for the observer. And the mappings are computationally simple and fast. So what are the two major color areas? Full color image processing, pseudo color image processing. Today we are discussing the pseudo color image processing. It is the under of major areas of color image processing. It is the second type. First type is a full color image processing. So full color image processing, the images are acquired with a full color sensor, that is a color TV camera or color scanner. Color TV camera, color scanners are the full color processing. Pseudo color processings are generated by assigning a shade of color to a monochrome intensity or range of intensities. These are dependent on intensity values. Intensity values can be changed. So pseudo color processing are the images that are generated by assigning a shade of color to a monochrome intensity or range of intensities. Pseudo color image processing approaches for assigning color to monochrome image based on properties of gray level content. Monochrome images, the term monochrome is usually taken to mean the same as black and white or more likely grayscale, but may also be used to refer to other combinations containing only tones of single color such as green and white, green and red. Green and white, green and red. So what are the three approaches? Intensity slicing and color coding, gray level to color transformation, filtering approach. So pseudo color image processing is assigning a color to monochrome images based on properties of gray level content. So actually pseudo color is nothing but we are changing the intensity levels. It is possible to change the intensity levels, and it is depending on monochrome images based. So monochrome images is nothing but it is usually taken to mean the same as black and white, but more likely grayscale, but may also be used to refer to other combinations containing only tones of a single color such as green and white, green and red. What are the three approaches? That means intensity slicing and color coding, gray level and color transformation, and filtering approaches. What are the two main categories of color image processing? Pseudo color image processing and full color image processing. Just now we discussed, but in depth we'll discuss now. and these are also called true color and false color. So already we know that pseudo color processing and full color processing, these are also called true color and versus false color. True color images are images with a natural color rendition. A red apple appears a red, blue ocean appears a blue, etc. It is difficult to achieve absolute true color in images, but being approximately close to human perception is acceptable. So, human visible system is accepting the color. Suppose apple is a red, ocean is a blue. That is the universal colors. So we don't have to change. We don't have to change. It is no possibility to change the original colors. That is a true color. So true colors are nothing but a original colors. False colors are nothing but, on the other hand, we are sacrificing natural color rendition in order to facilitate the detection of some objects. They are mainly used for satellite and space images. Actually, satellite and space images are the original images, but due to human visible perception. So, original images are to be changed due to human visual perception. That is a false color. True color is nothing but a original color. So, original color is a true color. False color is nothing but a original color. We are changing some modifications need as per human visual perception. That is a false color. So it is a sacrificing the natural color. We are sacrificing. Why? Because as per human visual perception or identifying image due to the identification of image in order to facilitate the detection of some objects. They are mainly used for satellite and space images. Pseudo color images are originally grayscale image which are assigned colors based on intensity values. Typical usage of these images is for thermography where the only available is infrared radiation instead of lights. Another example is a elevation map. So it is the input original image, but as per human visual system. So, as per human visible uh, perception, as per human visible, it is typical to see the image. So, that is the reason we have to need some modifications. That is called false color or pseudo color image. So, pseudo color is nothing but originally grayscale, which are assigned colors based on the intensity values. Originally grayscale, but you are applying the colors to that one as per human visual system or looking good or visual system or identification of the image. Due to identification, we are converting to the color or we have to some modifications in the original color. That is also called pseudo color or false color. It is a thermography where only available in infrared radiation instead of lights. Another example is a elevation map. And intensity slicing. This is a simple case of pseudo color image processing. It is also called density slicing or color coding. So imaging or image is a grayscale image as a 3D function with intensity being of the third dimension, placing a plane parallel to the horizontal plane for the pixel position coordinates would slice the image into two parts. After that, we can assign different colors to different levels. So, what are the intensity slicing? This is a simple case of pseudo color image processing. It is also called density slicing or color coding. The image or grayscale image as a 3D function with intensity being in the third dimension placing a plane parallel to the horizontal plane for the pixel position coordinates, and it would slice the image into two parts. After that, we can assign different colors to the different levels. That is also intensity slicing. So the functional block diagram of pseudo color image processing. So what is the pseudo color image processing? In the f of x, y is the input, that is a pseudo color. So what is it means? Red transformation, green transformation, and blue transformation. So output is of red is a fr of x, y, fg of x, y, fb of x, y. So these are called pseudo color. So it is the input image dividing as a input image dividing as a red, green, and blue. So we are combining of, we are dividing as a 1 plus 2. We are divided or separated. Or separated. So red transformation is separate, green is separate, blue is separated. So after the red transformation, fr of x, y, g is fg of x, y, b is fb of x, y. So full color image processing approaches fall into two major categories. Approach one, that process each component image individually and then form a composite processed color image from the individually processed components. Approaches that work with color pixels directly. In full color images, color pixels really are vectors. For example, RGB system, each color pixel can be expressed as C of x, y equal to CR of x, y, CJ of x, y, CB of x, y is equal to R of x, y, G of x, y, B of x, y. It is the image size of m into n with mn such vectors C of x, y for x equal to 0, 1, 2, so on m minus 1, y equal to 0, 1, 2, so on n minus 1. So, full color image is nothing but a true color images. The approaches that process each component image individually and then form a composite processed color image from the individually processed components. Approaches that work with color pixels directly. In full color images, the color pixels really are vectors. For example, in the RGB system, each color pixel can be expressed. So C of x, y equal to CR of x, y, CJ of x, y, CB of x, y equal to R of x, y, G of x, B of x, y. It is a m into n with mn such vectors are C of x, y. So full color image of is a C of x, y. So what is a full color means? A combination of red, green, blue. That is a full color. And pseudo color means we're dividing a red, green, blue, separating the colors. So color image smoothing is a part of processing technique intended for removing possible image perturbation without losing image information. And analog sharpening is a pre-processing technique that plays an important role for feature extraction in an image processing. A method of sharpening a digital color image that takes viewing condition and human visual mode into a consideration of describing. So, color image smoothing. Already we know that smoothing and sharpening are the two color combinations are there. Smoothing is for remove noise. So color image is a part of pre-processing technique intended for removing possible image perturbations without losing image information. And analog sharpening is a pre-processing technique that plays an important role for feature extraction in image processing. So smoothing and sharpening. Sharpening is for removing the blurring. Smoothing is nothing but removing the noises or unwanted data, and it is a sharpened digital color image that take the viewing of conditions for human visual model. So sharpening is nothing but as per human visual system, remove blurrings. So smoothing and sharpening are the two major techniques are there that plays an important role for feature extraction. Sharpening is nothing but a digital color image that takes viewing the condition of human visual model into consideration is described. And this method combines the Laplacian or Gaussian operator with spatial filters that approximate the contrast sensitivity functions of human visual system. The two important pre-processing technique with computer vision field is smoothing and sharpening. It consists of removal of possible image attributions result from image acquisition. Sharpening is nothing but improving the image visual system and removing the blurrings in detail, the enhancement borders of the image. There exist a lot of smoothing and sharpening methods that are able to improve visual quality of the image. So the method combining of Laplace Gaussian operator for spatial filter approximate to contrast sensitivity function of human visual system. So LVOG is nothing but improving the contrast, improving the contrast. So what are the two important pre-processing techniques or major role for computer vision of human visibility? Smoothing and sharpening. So smoothing consists of the removal of possible image attribution resulted from the image acquisition, and another one is a sharpening in the charge is in charge of the improvement of the image visual appearance and the enhancement the details and borders of the image. There exist a lot of smoothing and sharpening methods that are able to improve visual quality of images. Okay, it is one example of figure A. It is the original image and it is a smoothing. It is the input image and it is the output image. So you can see here in the input image what is happening means the sun is there. As per human visible, we are some typical to identifying the person. Who is the person here? So object recognition. So it is typical to finding out the object recognition. You can observe, see here, what is a background. Here some blurrings are there. We are not identifying what is a background here. Here we are identifying that it is a tree, but here it is not possible to finding out. But here the sun is there background. As per this one, where as per human visual system, this person is not visible. But here we are easily visible in system. Why? Because we are decreasing this one. We are decreasing the intensities. Here, input image is there, that it is a sharpening. We can observe here in the sharpening, the shed color, how much, and the background color. The bricks are there. What is the size of the each bricks? Each brick, you can find out what is the size, what is the background of how many bricks are there. So we can easily find out. Here, it is typical to find out. It is better, but typical to find out. And also, the shed color we are not identifying easily, and here we are identifying easily what is the original color of the shirt. So it is one example of original of smoothing and sharpening technique. And another one is a data compression, a central role in the storage and the transmission of color images, and that is a data compression. Compression means reduce the size. So data compression is a central role in the storage and the transmission of the color images. The red, green, and blue components of the images in the RGB image. That means the color information conveyed. Compression of the process of reducing or eliminating redundant or irrelevant data. That is a data compression. What is the data means? The pixel intensities. What are the pixel intensities are there? We are calling as per our digital system. It is nothing but a data. If we are changing the pixels means we are changing the data values. If we are removing the pixels means data means removed. It is a compression means we are reducing the original image, compressing the image. It is reducing or eliminating redundant or irrelevant data or unnecessary data. What is the irrelevant or unnecessary data we are removing or eliminating from the original? That is called the compression of the data. And what is the objective? To minimize the human number of bits required to represent an image. And image data compression methods fall into two common categories. That is the information preserving compression and the lossy image compression. So image preserving compression is nothing but a especially image achieving or storage of legal or medical records, compress and decompress image without losing information. And what is a lossy image compression? Providing the higher image levels or data reduction, result in a less than perfect reproduction of the original image. It is one example of color image. Is there figure A, original RGB image? It is the RGB, and the result of compressing the decompressing of image, compressed image, that is the output image, it is the input image. Okay, so today we discussed about the what are the color models are there. The primary colors are the red, green, blue. Primary colors are red, green, blue, and the secondary colors are magenta, cyan, and yellow. So what are the color combinations are there? So red, blue, and black are the color combinations of that in the normal gray to color images. And these are the color combinations: red plus green, yellow; green plus blue equal to cyan, and red plus blue equal to magenta. Red, green, blue is the white color combination. It is a block diagram of combination of colors. Okay, it is about the color models. Okay, thank you.
Like, share, and subscribe. Hit the bell icon for more updates.